The next topic in Unit 4 is source transformation. Source transformation is a method by which we can convert a voltage source to a current source or a current source to a voltage source. The method is mainly used for simplifying circuit solution because it uses only simply Ohm's law for the conversion. In order to understand the method of source transformation, we should first have an idea of what is meant by equivalent sources. The voltage source given here and the current source represented here can be called as equivalent sources provided they deliver the same amount of power to the remaining part of the circuit. Let us have a look at the practical connection of a voltage source and a current source. Practically, a voltage source is always connected in series with a resistance, and for a current source there should be always a resistance parallel to it. Now, this voltage source and this current source can be considered as equivalent sources if the value of Vs and Is are ruled by Ohm's law. So the picture that you find on the left side and on the right side, they represent sources. One is a voltage source and the other one is a current source, and they can be considered as equivalent sources. So let us have a look at the basics of source transformation. So here we will have a look at transforming a voltage source to a current source as well as a current source to a voltage source. So first of all, let us do a conversion of voltage source to a current source. As given here, you can find a voltage source which is connected in series with a resistance. So this one we have to transform it to a current source. So as you know, the current source is always connected in parallel with a resistance. So the first thing that you need to notice here is the resistance that we connected in series with the voltage source, the same amount of resistance will be connected in parallel with the current source. So it is the same resistance here. If here you have 10 ohm, here also you will be connecting the same 10 ohm. This is in series, this is in parallel. Now, another point is, what about the value of the current source, the new current source value? It is obtained by the simple Ohm's law, Vs over Rs. So, whatever was the original voltage source value, that voltage source divided by the resistance value will give you, of course, the current, and that current will be the value of the new current source. Okay. So now let us have a look at the reverse transformation. Imagine you are given a current source, of course connected in parallel with the resistance, and you want to convert it to its equivalent voltage source. The first step is connect the voltage source in series with the same resistance. Now to obtain the value of this voltage, you have to again apply the Ohm's law. It is Vs is equal to Rs multiplied with Is. So whether you want to convert a voltage source to a current source or a current source to voltage source, the basic rule for the conversion is nothing but Ohm's law. And another point that you need to notice is, in voltage source connection, a resistance has to be always connected in series, and when you do the conversion, the equivalent current source has to connect the resistance in parallel. Now, another point is about the polarity and the direction of the current source. You have to note one point, that when you do the source transformation, the head of the current source corresponds to the positive terminal of the voltage source. That means originally if the positive terminal of the voltage source is here, the converted current source arrowhead will be pointed upward. Or if the current source is provided with an arrow head up, its equivalent current voltage source will have the positive terminal on the top. So if it is the reverse direction, the positive and the negative will also reverse. Let us have a look at one example. So you are given here a problem. So a circuit is given and you are asked to compute the current through the 4.7 kilo ohm resistor, which is here, after transforming the 9 milliampere source, which is this one, into an equivalent voltage source. So you are asked to find out the current through the resistance 4.7 kilo ohm by doing a source transformation, which is the given current source has to be converted to its equivalent voltage source. Okay, so let us have a look at the picture again. So what we need to do, as you are told, the current source has to be converted to its equivalent voltage source. So let us consider that part alone. So we have the 9 milliampere connected in parallel with 5 kilo ohm. So this has to be converted to its equivalent voltage source. In order to get the value of the voltage source, we need to apply Ohm's law. So Vs is equal to Rs multiplied with Is. The value of Rs is 5 kilo ohm, the value of Is is 9 milliampere. So that gives you a value equal to 45 volts. So the value of the new voltage source is 45 volts. And you know now that the voltage source has to be connected in series with the same resistance. So it is the same 5 kilo ohm here but connected in series. So what we did now, we transformed the given current source to its equivalent voltage source. So now we can consider that this voltage source in series with the resistance can replace your old current source parallel with the resistance. So now the new circuit looks like this with a symbol or a single loop. Now look at the question, what you are asked to find out. You are asked to evaluate the current I, which you can obtain by writing a KVL equation. So have a look at the loop here. So we have the 45 volts, then the 3 resistors and another 3 volt. So let us apply KVL one by one. So what do you have? You have a plus 45, then you are here. So it is, if you mark the polarity plus and minus, it will give you minus 5k multiplied with I. Repeating the same procedure, you have minus 4.7k multiplied with I, then minus 3k multiplied with I, and finally you have another voltage source which is minus 3 volt equal to 0. Combining all the resistors 5k, 4.7k and 3k together, you can simplify the equation to 12.7k I, and 45 and minus 3 together will give you 42 volts. So the equation simplifies to 42 minus 12.7k I equal to 0. Now getting the value of I is now just one step more. I is equal to 42 over 12.7k, which is equal to 3.31 milliampere. So if you look at your original circuit and after the transformation, the new circuit that you got, you can see that the complicated circuits can be simplified to either a one loop circuit or maybe one junction, that is one node circuit.